All right, everyone, we are live, and today it's going to be a little bit more chill and slower than usual. I will try not to be too, I don't know, always on top of everything, just whatever happens, happens. The topic is autoscaling a job, like a worker who is supposed to process some unit of work, be that scraping a website or, I don't know, run an AI prediction, whatever. And we are going to autoscale this hypothetical worker with KEDA on Kubernetes. So basically, there will be a queue where I will just manually drop some jobs. It's basically just an entry into a queue. And this worker is going to be spinned up by the autoscaler KEDA. And it will consume the job. It will sleep for, I don't know, a random 20 seconds of something. And then it's going to stop. And I'm going to try to, submit like many jobs and then see how the autoscaler spins up, I don't know, 5, 10, whatever the maximum number of jobs will be. We'll spin up all these workers, and it's going to process these units, and they're going to stop. I definitely want to put this on the chart on like a Grafana UI. And I want to see the cluster autoscaler as well. So quite a few topics. I want to see the number of replicas increasing based on load, and I want to see the number of nodes the cluster has increase. So it's quite a job, quite a task, but I try to take it easy, so no rush here. The only thing I prepared is I have these wonderful labels, like we are going to install Redis and KEDA. Shouldn't take more than 5 minutes. We are going to write a simple consumer just in Bash with the Redis CLI and so on. And yeah, I have a few more of these little labels. And I actually have something as well. I look at other people's stream and there is music, various kinds of music. I never tried this, so let's see. Let's do this, people. Let me remove this banner because first I want to do the KEDA thing and I want to share my screen. So here we are. And first I need a cluster. Now, until now, I was using K3D local clusters in all my demos. They are fast, easy to spin up and down, and so on. This time around, I'm going to use a real cluster because I want to see the cluster autoscaler. And with K3D, I can't really autoscale a single node cluster. So I'm going to choose Civo for this task. I have an agreement with Civo, like a demo program, so I'm a member of that. So they gave me wonderful amount of credits, and I'm able to use their infrastructure. So you will also see Civo Cloud's Kubernetes cluster in action in this video. And first of all, let's get over with the cluster creation because that's not in scope right now. I just want a single node. Yeah, something meaningful. And yeah, what do I install? This is actually the last part to install the autoscaler, the cluster autoscaler. This should be the very last step, but let's actually go ahead of ourselves a little bit. So where is the cluster autoscaler? I will not use GitOps in this stream. I will not use Gimlet in this stream. I will just click and do kubectl applies manually. All right. I have no idea how to configure the cluster autoscaler, but we will figure it out later. So if I hit create cluster, it should get me a cluster rather soon. Yeah, it's gonna take a few minutes. Let me fiddle with my stream. If I have any comments or something. Not yet. All right. There used to be a time when Sivo was spinning up clusters like under a minute. I think last time I tried it was a minute and 20 seconds or something. So they shouldn't last too long. In the meantime, I'm going to look for the Redis Helm chart, because as I told you, I didn't really prepare any manifest, but I've done this a few times, so shouldn't be too difficult. Or I will peek into some of my notes from other projects or something. All right, the cluster is coming up live. And I'm in London. That's good to know. All right, I have a cluster. And I will just refresh this page just to help the UI here to get me a kube context. All right. And it was called Sivo Autoscaling Test Cluster Kube Config. Good stuff. I have some errors. Maybe the metrics server is not available on the server or on this cluster, but I don't care about that. I have a node and just a few pods. All good. I usually have 2 panels, so let me do the kube config trick here as well, just to avoid any cluster mismatch issues. Okay. So I have a cluster. Next, I was promising to install Redis and KEDA. So a Redis Helm chart. Bitnami has some nice Helm charts about all the things, and there is a Redis TLDR, run Helm install Redis. What can go wrong? Actually, this is the first time I see an OCI registry URL. I'm very conservative in that sense. I was aware that you can use an OCI registry, which is a container image registry for this purpose, but this is the first time I see a Helm chart in a registry. So how about I go at it and yeah, what can go wrong? Oh, let's call it my Redis. There are some help text here. I actually steal these because, again, I can use them later. So this is how to run Redis client in the default namespace. I don't know if there's a password or not. It's fine. What else is here? Support forward. I wonder from where Redis password will come. I really hope it's just like I'm able to log in without any passwords, because Don't care too much about passwords in this example. So there are 2 pods in the default namespace, and containers are creating. Let's look into the pod. So first it attached the disk, so that's why it took a bit longer time than expected, and now it's not even ready yet. Let's look at logs. Ready to accept connections. Amazing. Oh, yeah, whatever. Redis is. Okay, master is running, replica 0 is running, and then there is a replica 1. Yeah, that's fine by me. Let's try to connect to it because that's going to be important later on. So, do I have Redis CLI on my machine? I do. How do I exit Redis? Exit? Yes. So if I port forward, I'm going to do this in 2 steps. So I have a port forward. Nice. I have a Redis cluster. Oh no, authentication required. Now, where is authentication? So this Helm chart is actually more production ready than I expected. Yeah, I could update the deployment, but maybe it generated some password from somewhere. Empty string? Nope. All right, let's reinstall the chart with this setting. So Helm install, Helm update, I suppose, or upgrade. Password is going to be secret password. And yeah, Redis. Yeah, it's upgrade. It's called, what is it called? My Redis. And why do I need Redis in the first place? So I'm going to use Redis as a queue. There's going to be a Redis list, and that's going to be my queue. There are some libraries out there. I think there's a Go library even, which uses Redis as a queuing backend. So I just want to use this. I recently used this as a queue, so it's actually going to be easier for me if I use this over RabbitMQ. The password was secret password. Yes. Now I need a port forward, and we are almost there. Amazing. All right, I have an empty Redis cluster. So step 1 is done. And then step 2 is going to be installing KEDA. KEDA is a very nice project. Autoscaling, so when people talk about Kubernetes, they think that it's about scaling and auto-scaling even, but the built-in things are rather simplistic and it's not easy to use, honestly. But then KEDA came along, and it's a controller running inside the cluster, and it has scalers. And when I say it has scalers, it has all the scalers you need. For example, it has a Redis scaler, Redis lists. list-based scaler. I provide the access information. I provide the list name and the list length, that is my target length. And pretty much that's it. It is, of course, a custom resource and so on, so it's going to require some YAML, but KEDA is very handy, and it's at least 1,000 times better than anything else autoscaling in Kubernetes. And it is also a CNCF project and a CNCF graduated project, meaning it's legit. Use it production or anywhere else, and it's super useful. I love it. So I need KEDA. Again, just installing with Helm. KEDA core. And what is KEDA core? Is it even KEDA? Interesting. Helm install. So this is why I'm saying that Kubernetes is not that difficult if you know how you get around. Like, I'm installing random packages just like an apt-get install. So if you know the basics, how to navigate, how to look around, how to do Helm, install, upgrade, and so on, you can do quite powerful things without much hassle. So again, I'm just waiting for KEDA to launch properly. There's an admission webhook. Let's wait until it's ready. All right, so that's there. And you know, many controllers install their custom resources. And if I get all the custom resources in my cluster and grab for KEDA, I can see that there are a few new YAML types I can use. And scale jobs will be our main star of tonight. I'm going to scale jobs like Kubernetes jobs with KEDA and based on a queue length. So actually, the first part of this stream is done. So we are off to writing a simple consumer. Now, writing consumers are usually tricky because there are a few things they should adhere to. Let me collect them in a note. So this is a Kubernetes job, meaning it starts, it does its job, and then it stops. So the application should reflect that. If it performed the job, it should just stop and not like spin all the time. You don't need a control loop of any kind inside. You don't need to, The only thing it should do is that start up, then pick a work item of the queue, do some processing, and then be nice and just stop. Because KEDA, so the autoscaler, will instantiate these jobs. And your little code, or my little code that I'm going to write, should just start up, should just pick an item of the queue, do some processing and stop. So what is going to be processing in our case? It is going to be sleep, like a bash. So I'm going to write everything in bash. It's going to be a very simple script. And I'm going to Google my way because nobody knows how to write bash, or at least I don't. So I'm going to sleep for a random period, or maybe I can sleep for 10 seconds. That's fine. And how do I pick an item of the queue? Well, the queue is going to be in Redis. So how about I create this queue, like very simplistic again. I need my port forward back. And keys. Okay. I need to define a Redis list. Commands. Lists. So important comments going to be like how to check the length and how to check the items inside. But how do I push? All right, R push key element or elements. So how about I do, let's call it work queue, and I'm going to push an item inside. First unit of work with ID 1, and then 2, and then 3, and then 4, and then 5, and then 6, 7, 8, 9, 10. And I'm going to check the length of the queue. So I have a 10 long queue with work queue and start index 1 and index 100. So I have a queue with 10 items. So again, this is simplistic. I add the work units into the queue by hand, and my consumer is going to pop these items. So if we add from the right, maybe we should pop from the left, right? Haha. So if I do a left pop, this should pop 1. Pop, work, queue. And if I pop again, it's going to be number 2. All right. So the very complicated code that our consumer is going to do is we are going to pop an item from the left of the work queue. Then we are going to sleep 10. Then we are going to die. And for us to be able to talk to Redis, we need a Redis client. So the same way I am running Redis CLI on a host and a port, I'm going to do lpop work queue. And basically this one-liner connects to Redis and takes the leftmost item out of the queue. So as I said, this is going to be rather simple. This is going to be the command, and we're going to perform this inside the Redis CLI or Redis CLI image. So we are going to build an image. I need to push that to... No, I don't need to build an image. Listen, hear me out. Let's see if there are any comments. I'm getting lonely here. Maybe I do some retweets and stuff. Yeah, just hold on for a minute. I will be. All right. I just retweeted my own tweet with my company account. So we have a consumer in theory, and we now need to construct it. And I need to find an image which has Redis installed. I suppose there is an image with Redis CLI. it looks like I can use the Redis image. And if I recall this this command that was written by the Helm chart when I installed it, it gave me this this output. So I can use just the Redis image, which is the one I need. And I promise that I will not have any Gimlet or anything special in this stream, just good old bash commands. I'm actually going to use one of Gimlet's component, one chart, to deploy this little consumer to the cluster, because otherwise I would have to write my manifest YAML, but I actually don't want to do that because it is faster for me to write a values YAML for a Helm chart called one chart, and there's going to be a manifest YAML as an output for that. So let me just very quickly show you what I mean. Yeah, you need to add one chart, and I want to just copy this to my values YAML. So the image is going to be Redis. Tag, I don't care too much. Can I do latest? Yeah, there is latest. So I'm going to use the stock Redis image latest tag. And yeah, wars, I think I'm going to add the super secret password that we have. This is going to be an environment variable inside the pod. And yeah, latest image. And I want to run a custom command. So the custom command is going to be, again, I'm cheating because I've done this once and I don't want to do this like more than once if I don't have to. So this values YAML will get me a Kubernetes manifest with the deployment, and the command is while true, and then do stuff like this. Instead, I could already take this command that we just constructed together, which again pops from the work queue. So maybe I need to do this because I want to connect to the cluster. Oh, hold on. To the Redis cluster with Redis CLI. And the host name is going to be something in internal cluster address. The port will be Redis port, and the command will be this. And then I'm going to sleep 10 seconds. So the consumer will simulate some kind of length to the processing. Echo, and I'm going to add a few echoes just to be able to debug things. So echo, I am now processing. And then echo, done. And before everything starts, I want to do something like echo hello, or let's do some processing. I'm very sure of the that I'm making mistakes here. With multi-line strings, that's the like in DevOps, the biggest thing that you do is how do you encode multi-line strings into YAML and then base64 and then a secret and then to your app, and then like through like and the CI and the CI variable. So at least like 5-6 level of processing and how you get through your multi-lines. That's what you do in DevOps. And this is something you do when you are just new to DevOps, and this is what you do when you are in DevOps for a long time. So, but I try to not make mistakes. So let's echo. Let's do some processing. New line end, run the work queue, pop, and then new line, echo, I am now processing, and then sleep 10 and echo done. This looks good to me. And I told you that this little Helm chart, cd projects, delete me, and then what's this autoscaling? That if I do Helm template, consumer one chart / one chart -f values YAML, and the output the manifest YAML, it gets me the Kubernetes YAMLs that you don't want to write usually. That's the 100 lines I spared. So config map, just to store our secret, which is not really a secret anymore. And then there's a service for the consumer. It has a port and stuff, but honestly, it's actually, I need a job. So I'm not going to use this as the output, but yeah. Soon I'm going to pick and choose parts of this YAML. And then deployment, which does something in the Redis image, calls a shell and does the multi-line stringy, which again, never works at first. So if I deploy this, it will start up, pop an item, and it will stop. So actually I could validate if at least the basics I did is correct. So why don't I do that? And also, why don't I print the ID of the work item? But let's do step by step. Let's go step by step. Inside the cluster, how do I access Redis? There is my Redis headless. This is the service inside the cluster I want to talk to on the regular Redis port. So, and I'm going to deploy into the same namespace. Where is it? Is it default? Yes, it's default. I love that. And my deployment is default namespace. Default namespace. Good. So again, I'm going to talk to my Redis headless. That's the service name, or that's the host name. And just to be a nice person, just a good citizen on Kubernetes, and in general, this would work. I'm pretty sure of that. But it's always better if you use fully qualified domain names, because of, I don't know, DNS is sometimes tricky. So it's better if you go fully qualified FQDN, and in Kubernetes this is the short hostname if you are in the same namespace. But you can do Kubernetes SVC local address, kind of. SVC namespace SVC cluster local. So if I do this default SVC cluster local, this This is a fully qualified domain name inside Kubernetes. It knows that this is in the default namespace and it's a service and so on, yada, yada. So if I generate the manifest again, and if I get what is in here, there's manifest YAML and there's Redis. And if I apply this, the best thing that can happen is that it will pop an item of the queue. And the worst thing that can happen is I have no idea. So let's see. Continuous creating. Let's look at some stream stuff. No comments. Okie dokie. So the consumer is running and still running and still running. It should be dead at some point. Yes. So in like 25 seconds, it started up and then it stopped. And that was most likely because of the image pool. It took some time. If I do a logs of it, let's do some processing. Oh, Redis says that I'm talking to a read-only replica. That's fine. No, actually that's not fine, because lpop is a write operation. It pops an item of the queue. It's strange that my Redis headless was connecting to the replica, most likely. How about I use this instead? I'm fine with that. I'm not too opinionated. I just find it strange. Again, Helm template, apply, and get pods in watch mode. It's running, and soon it's terminating or completed. Yes. And it's running again. That's strange. Please remain completed. Okay, and the logs. Okay, lpop wrote that number 6 was the work item I processed. Good. So the basic, I think the consumer is kind of done. It does what it has to. So let me just push the label to the next item, which is autoscaling manifests. Let's go to the KEDA page, because KEDA has some nice examples. Scalar, Redis list, example. Let's take the full example and then try to make it our own. So this was the pod consumer pod, and I'm going to create a scaled job. The scaled job is a custom Kubernetes type, which was introduced by KEDA. Scaled object. Object. I'm looking for a scaled job. This is not what I'm looking for. Redis lists. So let's search for scaled object. Scaled job. Maybe I start from here. sample. So scaled job is what I'm looking for. I'm gonna call it all over. I'm gonna call it Redis consumer. And I'm gonna borrow a few things from the pod-based implementation because I need the I don't use a secret because there's nothing secret about this right now. So I'm gonna use a config map. And yeah, I'm just gonna delete the Helm boilerplate. It's called Redis consumer config map. Default namespace, Redis password. Good. I actually go back to the secret and I use string data and borrow just the value. I realized that I would have to rewrite this part, like the secret reference, to a config map reference, and that would be just a source of errors, like a small one. So this is easier. I have a secret in the default namespace with Redis password. And then the Redis consumer is going to be a type of scaled job, which is a KEDA resource, which will create jobs based on this template. So I'm going to copy over the pod configuration in here, but let's go step by step. The scale job, Redis consumer, default namespace. I'm going to create a job based on this template where I'm going to run a container that is basically the same as here. It has a few things. Scale job. And of course, indentation. So I don't need a security context. I do need a name. Let's call it consumer. I'm fine with that. I have the command. I have environment stuff from the secret. I don't need a port. This is a job after all. And I'm going to need resources because remember at some point we are going to autoscale, and how else would we scale nodes? We would have to tell the autoscaler and the cluster that how big a job is. And it's, it's going to consume 200 megabytes of memory and 200 milliseconds of CPU. And of course, it will not do that because this is a bash script. But Kubernetes only knows what you tell him or tell it or her. Oh my God. Apologies. So resources, limits, requests. We are done with this part. I'm gonna keep restart policy never because this is some job thing and I trust whatever is inside here. Back off limit is something about the jobs, like should we, I don't know, like how many times it should retry. This is more interesting about the, now we go into the scaling part, like we are telling KEDA how often it should check the Redis list and so on. And actually the trigger is still RabbitMQ. So now is the time to go back to the docs and go KEDA, scaler, Redis list. This is a trigger with all the parameters. Indentation again. So everything should be one to the right. Yes. So goodbye RabbitMQ. Hello Redis. Address, we know that. The consumer pod had it nicely. And here, the fully qualified address actually comes handy because KEDA is in the KEDA namespace while the Redis cluster is in the default namespace. So good that we used an FQDN. Password from the env, Redis username, Redis password. I actually don't know if a trigger, like how to provide a secret for this. So please allow me to actually cheat a little. I might come back and refactor. Optional. No, this is the hold on. So password from env. This is a bit strange. Like, I know that I use this consumer or this secret in the actual worker, but I also need to tell KEDA this parameter. So maybe I bring back the RabbitMQ stuff. There was no secret in there. So somehow I need to inject this secret, and I have no clue yet how to do that. But at least the name of the environment variable matches. So Redis_password, Redis_password. I don't need a username. And the list name is, we know that, it's called workq. Yes, it's called workq. And these are important. Like when you scale, autoscale, you always need a target number. Like how many items. So it's easier to grasp if it's a CPU usage-based scale. Let's say your target is 60% of your CPU. And if it's below that, it will not scale. But if you have 100 replicas and all of them are, or most of them are over 60% usage, it will scale. With queues, this is a bit different because we can read what's the list length actually mean. It's the average target value to trigger scaling actions. Like what's an average target value? Like if you have 100 instances of this worker and you have 500 queue items, then on average, one worker is responsible or will process 5 items from the list. It works statistically, but I found in the past that it's very difficult to actually reason about it. So in this demo, I think I'm going to set it to 1, meaning if I have a queue length of 5, I should better scale up. I should better scale up fast. So on average, each worker should be responsible just 1 work item. Yeah, all this is not really important. And a few more scaling things. Every 10 seconds, it's going to poll. Yeah, make it a bit faster. I'm going to scale until 30 replicas. That's a massive. But maybe it's going to be useful for our scaler. Maybe I will have just 10, just to keep it manageable. And these are just for you to really feel how the scaler works. Successful jobs history limit, meaning it means that it will keep around some jobs, so you can really look at their logs and just get the feel for them, like they're actually working fine. So I'm going to leave like 3 around, or maybe actually I could just delete them. We will follow them in action. So maybe I will not keep anything around, anything that was successful, but for unsuccessful things, I'm going to keep quite a lot around. Scaling strategy. Yeah, I think we can have a good demo without these. All right, I actually want to deploy this. So there will be an error, I'm sure of that. But if it succeeds, what I expect is that I have like 4 items in the queue left because I queued 10. And it's going to spin up 1, 2, maybe even 4 workers if it's fast enough, because the workers are quite fast. Maybe too fast, because they only sleep for 10 seconds. Maybe I leave them around, so like a job should process for like 30 seconds. So we should actually see them running. So if I deploy this, we should see a couple of those pods. Oh, that's nice. Crash loop back off. Maybe it's maybe because it was a pod and it was completed. Maybe Kubernetes restarted it, and it actually slowly ate all my queue because of this is a pod-based consumer. This is really not made for this. So I'm gonna delete this kdelete -f manifest. kdelete-f consumer pod. Yeah, I don't need any of this. And then go back to port forwarding, because now my queue is empty. And I'm going to go back to Redis CLI. Yeah, it's empty. So how did I do it? rpush again, 10 elements, and maybe I push 10 more. And now the length, and then the queue. Yes, I have 20 elements. I take off this massive it's getting dark here, and maybe colder a bit. All right, so I think we are very close to actually scale stuff. So let's look at those pods. And here we have the scaled job again. I will do a recap of this, but basically we made this a consumer. Yeah, I will recap, it's fine. So apply -f scale job. Create the scaled job. And oh, so many consumers happening. It is happening. It has 2, 3, 4, 5, 6, 7, 8, 9, 10. So I already have 10 pods because guess what? That's the maximum number of replicas we set. And we have 20 queue items. So they should really stay at 10 consumers until all the 20 replicas are consumed, or the 20 work items are consumed. And actually, if I come here and I go back to Redis, I can really follow. Yeah, we have 8 more still. And I can open up one more. Export cube config equals downloads Sivo autoscaling cluster cube config. Yes. Good. We have 7 still. And now we should have 7 pods that are running. Consumer 2, 3. We have 6. All right. Yeah, in the meantime, the queue only has 2 items left, so soon these workers gonna spin down. They each process for 30 seconds, so that's why we are seeing them. But slowly they are stopping because they did their job. And now there are no more workers, and still 2 left in the queue. That's odd. No, not anymore. So that's 0. Oh yes, because the last 2 consumers were spinned up. So yes, everything is accounted for. And in 20 seconds, they're gonna stop. So I think we had a nice scaling happening. I think it would be super cool to see them on the chart, like queue length going up and then queue length going down. And for that, actually, we should have like Prometheus, Grafana, and metrics and all that. So that's one route we can go. And the other one is the cluster autoscaler, which could be also interesting. And we are 1 hour in the stream. Actually, it would be nice to do both. Let's do some twittering. All right, so I'm gonna do both because in 1 hour we could really go through the manifest, the autoscaling, and so on. So maybe I do the visualization right now. And now we're gonna go metrics and gonna change the music here because I'm a little bit already flown away feeding the ducks. That's fine. All right, let's do autoscaling metrics. We need a few things here, actually quite a few things. We need Prometheus. We need Grafana. Yeah. And we also need some scraping and oh my goodness. Now I could use Gimlet's bootstrapping And can I do that? Yes, I can do that. All right, folks. So I'm going to do that because firing a Prometheus, setting the scraping based on the right labels and so on, and the dashboards and stuff, it feels more productive if I do that. So but actually I'm going to use the CLI and create a stack with, I'm going to use this Gimlet stack thing. Maybe I also need to bootstrap GitOps for, no, I don't need to bootstrap because I can apply the manifests by hand. Yeah, the problem is I feel a bit tired for this. Maybe I go straight to the cluster autoscaler. Yes, use Gimlet. Thank you, Sultan. Oh no, oh no, oh no, oh no. It means I have to do this for real. Thank you. So I'm going to do autoscaling metrics. And for that, I'm here and I am going to now, this is something I haven't done for a long while, like bootstrapping GitOps from the command line and using this part of Gimlet. I'm using the dashboard like almost exclusively. So this is going to be fun. Gimlet, GitOps, Gimlet GitOps Bootstrap. It has some help text. Thank you, Past, Laszlo, and others. Gimlet GitOps Bootstrap. I'm going to bootstrap a single environment. And I'm going to create a repo for this. And my repo is going to be a personal repository. So let's go new under Laszlo CPH and call it GitOps scaling 123 infra. It's going to be a private repo and I will not initialize it. Good stuff. I have an empty Git repository. Maybe I'm going to rm the README and then do Gimlet GitOps Bootstrap and using all these lovely help. And the URL is going to be Laszlo CPH and GitOps scaling infra Git. And what else do I need? I need a controller, so I don't have to set this. I don't need dependencies. Let's go full on testing here. My colleague Adam's gonna love me tomorrow when I'm gonna dump all the bugs at his desk. Like, why this doesn't work? And if I do this, It's written like this. Okie dokie. Is this a private key? No, this is a public key. So inspect the configuration files, then commit and push the configuration to Git. Okay, I have a bunch of files. Flux and the deploy key, which I will not show to you, and a bunch of YAML to bootstrap GitOps. So if I inspect it, that's cool. I need to push it, and I also need to add this deploy key. So let's go step by step. Git add dot git commit manually bootstrapping GitOps with that. I have all the things. Next is going to be step 2. This is a public key. I should add this to the deploy key section. Let's call it Flux, because Flux is going to use this. And this is a read-only key, because Flux is going to just read. Good stuff. And step 3, apply all the things on the cluster. Is this the right cluster again? Oh, and I have 2 nodes. Look at this. I am autoscaling already without knowing about it. So once I will have metrics and nice charts going up like queue length, I'm going to add another metric, which is called nodes or node count. And I should really correlate with this scaling that just happened automatically because of this autoscaler component. It happened automatically without me knowing it, so that's brilliant. But I also want observability. I want to be able to tell, like, yes, this scaled because at that moment of time there was this many number of workers. So that's going to be a very cool demo. Yeah. So I was at step 3. I was looking at applying all these thingies, and I was looking at the nodes just to be certain that I am looking at the right cluster. And if I do this, applied all the things, this is bootstrapping, like applying the YAMLs just this one time to the cluster. Yeah, there was some line break problem. So if I make things small for just a bit, I can copy it for good. I really hope. How about I hope it works. Good. So now I have Flux running inside the cluster. There is a Flux system namespace. All the things are running. And I have a Git repository resource, again, a custom resource, which defines the link between my cluster and Git. So actually there is this SSH URL, like Git URL, from where Flux is going to get the good YAML stuff. And actually there is one more component here, which is the customization. And this is actually telling Flux which folder to apply, and I say apply all the things. So anything I put inside this Git repository is going to be manifesting on my cluster. All right, this wasn't too bad. We have a working GitOps automation. And then there is another thing, Gimlet stack, which I also haven't used from the command line for a good while. I'm going to, so Gimlet stack is a tool that has a bunch of curated Helm charts packaged together, Prometheus, Grafana, yada, yada, and it will manage the YAMLs inside this folder. It just works with files, so I'm able to really showcase everything here. So I'm going to launch Gimlet stack configure. Again, something I haven't done for a long time, but this brings up this little UI. And I'm going to pick Prometheus with default settings. I'm going to pick, yeah, Grafana is installed by default if I have Prometheus. So yeah, I close the tab and write the config. So there was a file created called stack.yaml. And inside the stack.yaml, there is very little. Again, let's look at the file. Stack.yaml is like sort of your orders in the marketplace. It's going to use Gimlet Stack version 0.28, and it's going to enable just the Prometheus component. And this is Gimlet specific, but the moment I run Gimlet Stack generate, it generated a bunch of things. So suddenly there are like six new folders. In the ham releases, there is Prometheus, there is Grafana. In the manifests, there are a gazillion number of dashboards. So this is all good stuff. And there's data source, like Prometheus is configured in Grafana. So all that is nicely put together. There is just one thing inside the dependencies folder, which I actually, when I bootstrapped GitOps, I told that I should not have dependencies, but Gimlet Stack creates dependencies no matter what. So I just moved this to manifests. This is something, workflow hiccup that maybe we should address. But here I have all the YAMLs and all uncommitted. And GitOps is happening, guys and girls and people. Get customization. So it's already applied this D02 commit. What's the latest commit here? Yeah, I was way too slow. GitOps is faster than you. It is already running Prometheus inside the infrastructure namespace and Grafana for that matter. Pods are pending. Let's go to MS infrastructure. Get the pods. Pending because maybe there is not enough room for them, or maybe, again, this is going to be disk, perhaps. No idea. But the describe gonna tell me. Successfully assigned a node. Yeah, I just have to wait, I suppose. What about node exporter? So this is actually a very interesting describe output. Basically, it's pending because it cannot be placed on any node. Probably there is a node that is full already. And not even this daemon set pod can be scheduled. That's odd. This node is far from being full. And then the other one is probably the same. Yeah, these nodes are not full at all, and still the node exporter cannot be scheduled on them. So let's look at the reasons once more. At the end of the day, I don't even need node exporter because I don't need node metrics in my demo, but let's spend 1 minute with this. 3 ports, okay. Didn't have 3 ports for the requested pod ports. That is something maybe a permission issue. So port 9100 cannot be bind. Probably it's even using host networking. Yeah, this is host port. So most likely this is a CVO specific thing that I should work out. But I don't need a node exporter right now. I'm just looking at what could be the pod that is occupying. Metrics server is there, but it's not. Most likely CVO is running their own node exporters on this port. So maybe if I use a custom port, I would be able to deploy the node exporter, but I don't care, to be honest. I don't need node metrics. Let's focus on the good stuff. So I have Grafana. And I could port forward this Grafana. So I just exposed this Grafana port on my load. svc/. Yeah, I've done this before. I have no idea, but port 10,080 is some restricted one because of some malware or something. All browsers block that. That's kind of an interesting thing. But I have Grafana and I need to log in, and there is usually a password inside the Kubernetes secret, like how to get it. I always forget how to do that, so this is a flex, but Gimlet Stack has a little one-pager for each component, and even I just come here, and in the one-pager, I copy this to get the secret with the password. Yeah. So close this guy, get the secret, which is this, do the port forward again, go to Grafana, admin user, and ta-da! I don't have broken pipe. Please work. I have dashboards. In general, I have cluster metrics. Again, like load and CPU and this guy ops and all that is not available because of the node exporter issue. But I have like how many things are in the cluster, like total CPU cores booked and so on. And what else do I have? I could look at the namespace. In the default namespace, I will be able to track memory usage of Redis and my consumers. But I'm going to start a new dashboard because I want to picture a few things. Not a panel, sorry. Let's add a new dashboard. New dashboard. This is a new dashboard. Let's save it. Let's call it Autoscaling. I will be back in a moment, guys. I need a short break. I was muted. All right, so I actually want to do the metrics because it's going to be beautiful at the end. And I have an hour more, and you can always disconnect and come back when you have time. So no worries there. Just wanted to say hi, Anton, as well. I know a few Antons. You might be the one, I know. And we are back to auto-scaling metrics. And let me add my screen back. And some Grafana paneling here. That's always interesting. I'm looking for a metric called, I don't have a node exporter. So load metrics are actually not available. That's too bad. Because usually I look at the load metrics of each node and then I count the distinct label sets. So that would be node count. But maybe there is some other node metric without the node exporter. Yeah, look. Cluster autoscaler nodes count, run query. It says 2 and this says 0. And it's again, the trick is inside the labels, like, there is different state of each node. So give me like code, not like this query builder. All right, I like the, how do you call it? The type ahead, the suggestions here. I'm looking at ready nodes and I have 2 nodes. That's cool. In the last 30 minutes, I was having 2 nodes all the time. So this is the first interesting label I need. Oh, edit. And let's call it label name node count. All right. So I have node count. This is too large. Can I go smaller? I accidentally pushed something and it became huge. We are going to have just one panel, so it doesn't really matter how big it is, but I now wonder like why this is so big. Yeah, whatever. All right, so I have a node type and I need a queue length as well. And for that, I would need to have a Redis metric. How to extract metrics with Prometheus. There is usually an exporter, and I doubt that there is a Redis exporter that exposes the actual keys inside, but let's look at Redis Prometheus exporter. This is some random person's random project. I don't necessarily want to deploy this. I might, because there is nothing in this cluster that is, confidential in any ways. So I could do that, but also can look at Bitnami Redis. It is most likely has a Prometheus exporter endpoint. Metrics enabled. Start the sidecar Prometheus exporter to expose Redis metrics. Good. So I can modify my Redis deployment and I will have some metrics. I don't know what metrics, but I will have some metrics. So if you recall, in the very, very beginning, we were doing ham install. Redis, and I can do -- set metrics enabled true, perhaps. I usually use a values file for ham, so pardon if I'm making mistakes here, but And again, it should be I installed Redis in yet another namespace. I am dumb. So Redis ham rm ham uninstall. Yeah. ms default and upgrade. That was my Redis. Yes. Let me add the metrics enabled flag. All right, they are restarted. Let's look at the stream. Sometimes I forget to unmute myself. Almost there. Now, Prometheus should scrape this by default. I might need to add a few labels. Okay, let's go to Prometheus and actually verify if this Redis is being scraped. So infrastructure and port forward. Prometheus server port 9000. So we are going now very cluster administrator-ish, but yeah, maybe you can fast forward to the end once we are done. Prometheus server. Oh, 1990, yes. So this is Prometheus underneath Grafana. Nobody usually uses this except when you want to debug things. And I just want to look at what is being scraped by Prometheus. Nodes, C-advisor, pods. Is there Redis somewhere? My Redis is scraped. Good. So actually I could have some metrics already. So let's go to the Explore view of Grafana. I'm missing the port forward. Or am I? Yes. So if I type metric something Redis, yes, too much metrics, too many metrics. I actually want to run a custom command, which is, it's not going to be the metric I want. Key space, blah, blah, blah. It was a bit of an effort, not very useful, because I can get a bunch of inside metrics of Redis, like all the things, DB keys, but not really about the actual keys, like the value of a key. What is this? No, this is, yeah, Redis can have multiple databases. Too bad. Because usually the queuing system that I use exposes this metric. KEDA? No, KEDA has no metrics. Let me cheat a bit. I had a project some time ago where we have this. No, that was different. All right, so maybe we're gonna have to live without one of the most important metrics, which is queue length. I am sorry about that. What we have is node count, and I'm also going to add worker count. Add the new query, pod, queue pod container info. I just need what's inside. Pod. I want to count the pods which start with, how do I call the scaled job? Redis consumer. So maybe just anything that is consumer, like regular expression, and call this metric. We're gonna count this. We're gonna count this worker count. No data so far, but let me do a quick scaling again and see what pops up. So again, we don't care about Prometheus, we care about Redis. So if we do port forward Redis, and we are going to do Redis CLI, the queue length is 0, and instead of that we are going to go inside Redis and we are going to queue 20 items. Yes, so the oh, the scaler already works. So yes, stuff is happening in the background. So 10 was already popped off the queue. So we have 10 workers here. I really think it's going to show up here like very soon. Refresh. Maybe the metric I'm looking at is not the best. I am ending the show latest at 7:30. So if you think that this is getting long, there is light at the end of the tunnel because we are close. Let's look at these metrics. Metric cube pod. What? Cube pod info. Go. Select label. Pod. equals Redis consumer. Ah, yeah, there was an issue with the actual name of the pod. So the metrics are there, but it's not called consumer, it's called something consumer. Yeah. So last 5 minutes, we had 10 consumers. We had 2 nodes, and it slowly decreased down to 3 because most likely the queue is very much consumed already. So if I come here and look at pods, none are running, and the work queue length is 0. So I'm going to repeat this a few times because I even want to see like a node count going upwards. So how about I pause the job, the scaled job, get scaled job, active false, ready true. Maybe I can do a quick pause or like suspend here. Export editor equals no KEdit. I can just apply here from here. Scaled job. How do I suspend the scaled job? No idea, but KEDA is very helpful. Suspend. No. Stop. No. Yeah, I will be just very nasty. I will set the maximum replica count to 0. I apply this. Applies F scaled job. Get scaled job max 0. So if I add stuff now to the queue, it's going to stay there. When things are dynamic, it's very interesting sometimes that you can't think about all the factors here because, yeah, it's difficult. So I'm going to queue 1 time, 2 times, 3 times, 4 times, 5 times, 6 times, 7 times, 8 times, 9 times, 10 times. And look at the length. There are 100 work items. I'm going to look at the autoscaler because I want to know like how big this can get. I suppose there's a config map somewhere, like the node autoscaler. It's in the kube system namespace. Cluster autoscaler status. Max size 10. So we have room to scale. And another thing is so like 10 instances of this job is going to consume 2 CPUs, like 2 cores completely. And I think we have 2 cores per node. So if I set the maximum replica count to 30, that's 3 nodes that is required to consume the jobs and all that. Plus we need another node because of all the other things. So if I apply this, we should see the worker count to go up to 30 and the node count to 4. So let's apply it. Apply href scale job. Get scaled job 30. And I think we already have some consumers. Maybe I killed the cluster already. Wow. I killed the cluster. Server unreachable. What happens on the other ones? But this is just the control plane. I'm not sure what happened, honestly. It's going to come back online. And even my port forward is dead. That's bad. Let's go to... I can see that it's scaling, so, and it's at 4 nodes, so stuff is happening in the background. So that's the nice part of containers, that those nodes are actually there and working. Just your control plane is sometimes it's perhaps not highly available. So when it's upgrading, perhaps it's just not available. So things are running. I just don't see it. Like you fly blind. I was expecting 4 nodes, yes. Yeah, let's see until the scaling is done. Let's wait until the scaling is done. Yes, so pods are running, a bunch of them. Prometheus, I hope it was capturing data because, hey, it was running on the node, just the control plane was down. Let's do a port forward for Grafana. And quickly, yes, what do I see here? We have 26 workers and 4 nodes, and there was an outage here about an outage of the observability as well. So something fishy was going on, but self-healing and Kubernetes and all the good stuff was solving the issue. All right, so we are at 4 nodes, and the worker count is decreasing. Most likely the queue is decreasing as well. So if I do a length, again, this needs to be reinstated. Yeah, we are at 38 queue, so I'm not sure why it's decreasing. Wait, so there was a point where we had 42 workers. Maybe it was counting the completed job as well or something. Yeah, 22 workers. Yeah, we are at 15 jobs, so that could be fine. I could track this down, this bump, because this is higher than our max, but I just leave it at that. We can see the number of workers. That's cool. We see the node count increasing. We have seen a hiccup during autoscaling. The master nodes were not available, so that's strange. And I couldn't get the Redis queue length onto this chart, but yeah, at another time maybe. And as a recap, what we did is there was a very simple consumer, which is basically comes to life inside the Redis CLI image, pops a work item of the queue, and sleeps for X number of seconds, because that's how we simulate work. And then it prints, I'm done. And then I put this inside a scaled job YAML, which is a special KEDA type YAML, which has some nice scalars. No, this is the one, sorry. It has nice scalars. I picked the Redis scalar. There is the documentation with 50 different scalars. So all the queue engines are there, and all the things that you want to use. And I scaled based on a queue, and maximum replica count was 30 at the last example. Yeah. So this is 50 lines of YAML plus the observability things we did. And by now, queue is empty. Yes. And we don't have consumers, any consumers. So this is just an artifact of Grafana, that when it doesn't have a metric, it doesn't show 0, but it's 0. It's just cut off. And over time, this autoscaler would scale down, would save us some money. Yeah, I'm happy. Thank you for your attention and stuff. It was an hour and 45 minutes, and we almost did what we wanted. Yeah, we did most of it. So thank you, Zoltan, for the cheering and Gimlet help, and Anton for saying hello. And until next Monday, see you everyone, and have a good evening.